Important questions of software engineering for RGPV exam part 3. Question 5. Explain the difference between the black box and white box testing. Black box testing and white box testing are two distinct approaches to software testing that focus on different aspects of the software system. Here's an explanation of the differences between the two. Black box testing. Black box testing is a testing technique that focuses on the functionality and behavior of the software system from an external perspective. Testers performing black box testing do not have access to the internal structure, code, or implementation details of the software. The tests are designed based on the software's requirements and specifications, without considering its internal workings. Testers treat the software as a black box and focus on validating inputs, outputs, and system interactions without knowledge of the internal logic. Black box testing is primarily concerned with ensuring that the software functions correctly and meets the desired requirements. Test cases are designed to cover different usage scenarios, boundary conditions, and user interactions. Testers evaluate the system's responses, errors, and behavior without any knowledge of the internal code or design. Black box testing techniques include equivalence partitioning, boundary value analysis, error guessing, and use case testing. White box testing. White box testing, also known as structural testing or glass box testing, focuses on examining the internal structure, design, and code of the software system. Testers performing white box testing have access to the internal details of the software and use this knowledge to design test cases. The tests are designed based on an understanding of the software's internal logic, control flow, and data structures. Testers examine and validate the system's internal components, such as individual functions, algorithms, and modules. White box testing aims to ensure that the internal workings of the software are correct, efficient, and optimized. Test cases are designed to exercise different paths, branches, and conditions within the code. Testers evaluate code coverage, branch coverage, and path coverage metrics to ensure that all parts of the code are tested. White box testing techniques include statement coverage, branch coverage, condition coverage, and code reviews. Question 6. What is the purpose of maintaining the software? Explain the different types. The purpose of maintaining software is to ensure its optimal functioning, performance, and reliability throughout its life cycle. Software maintenance involves making modifications, bug fixes, enhancements, and updates to address issues, improve functionality, and adapt to changing requirements. Here are the different types of software maintenance. 1. Corrective maintenance. Corrective maintenance focuses on fixing defects, errors, or issues in the software system. It involves identifying and resolving bugs, performance problems, or any other anomalies that impact the software's functionality. The goal of corrective maintenance is to restore the software to its desired state and ensure that it operates as intended. 2. Adaptive maintenance. Adaptive maintenance involves making changes to the software to adapt it to changes in the environment, technology, or user requirements. These changes are typically non-functional and aim to ensure that the software remains compatible, compliant, and usable. Examples of adaptive maintenance include upgrading the software to work with new operating systems, databases, or hardware, or modifying it to comply with new regulations or industry standards. 3. Perfective maintenance. Perfective maintenance focuses on improving the software's performance, efficiency, and user experience. It aims to enhance existing features, optimize code, and streamline processes. This type of maintenance involves making modifications to the software to add new functionality, improve usability, or enhance performance based on user feedback or evolving business needs. 4. Preventive maintenance. Preventive maintenance involves proactively identifying and addressing potential issues or risks in the software before they cause problems. It aims to minimize future maintenance efforts and ensure long-term stability. This type of maintenance includes activities such as code refactoring, optimization, and security updates to prevent future defects, vulnerabilities, or performance bottlenecks. 5. Emergency maintenance. Emergency maintenance is performed in response to critical and urgent issues that require immediate attention to prevent severe consequences or disruptions. It typically involves quickly diagnosing and resolving critical problems to restore the software's functionality. Emergency maintenance is unplanned and reactive, focusing on resolving issues that pose an immediate risk to the software system. Effective software maintenance is essential to ensure the longevity, usability, and value of software systems. It helps improve the reliability, performance, and security of software, adapt it to evolving needs, and address issues that may arise during its operational phase. By performing various types of maintenance activities, organizations can minimize downtime, maximize user satisfaction, and extend the lifespan of their software systems. Question 7. What is a test plan? What are the different parameters used for testing? Explain. A test plan is a document that outlines the approach, objectives, scope, and activities of testing for a software project. It serves as a comprehensive guide that describes how testing will be conducted, including the test objectives, test strategies, test environments, test deliverables, and schedules. The test plan provides a roadmap for the testing process, ensuring that testing activities are organized and executed effectively. Different parameters or components included in a test plan are: 1. Test objectives. The test plan clearly defines the objectives and goals of the testing effort. This includes what aspects of the software will be tested, such as functionality, performance, usability, security, or compatibility. 2. Scope and coverage. The test plan outlines the scope of testing, specifying the features, modules, or components that will be included or excluded from the testing process. It defines the extent of coverage to ensure that all critical functionalities and scenarios are tested. 3. Test approach and strategy. The test plan describes the overall approach and strategies that will be employed during testing. This includes selecting the appropriate testing techniques, test levels, e.g., unit testing, integration testing, system testing, and test types, e.g., functional testing, regression testing, performance testing. 4. Test environment. The test plan identifies the necessary test environment, including hardware, software, networks, databases, and tools required to conduct the testing. It ensures that the testing environment is adequately set up and supports the execution of test cases. 5. Test deliverables. The test plan specifies the deliverables that will be produced during testing, such as test scripts, test cases, test data, test logs, defect reports, and test summary reports. It outlines the format, structure, and content of these deliverables. 6. Test schedule and milestones. The test plan includes a timeline that outlines the schedule of testing activities, milestones, and dependencies. It ensures that testing is aligned with the overall project schedule and allows for effective coordination and resource allocation. 7. Test execution and defect management. The test plan describes the process for executing test cases, recording test results, and managing defects. It defines the roles and responsibilities of the testing team, the steps for defect reporting, tracking, and resolution, and the criteria for test completion. 8. Risk assessment and mitigation. The test plan identifies potential risks and issues that may impact the testing process. It outlines risk assessment techniques, risk mitigation strategies, and contingency plans to handle unforeseen events or challenges during testing. 9. Test team and responsibilities. The test plan defines the roles and responsibilities of the testing team members, including test managers, test analysts, and test engineers. It clarifies their tasks, communication channels, and coordination within the testing process. 10. Approval and sign-off. The test plan specifies the process for obtaining approval and sign-off from relevant stakeholders, such as project managers, clients, or quality assurance managers. It ensures that all parties are aware of and agree to the proposed testing approach and activities.